Hello. Hi guys. Good evening. Am I audible to you? Hello. Am I audible? Okay, fine. You can see my screen and also I am audible to you guys, right? Very good. Fine. So we will wait for some more time. Okay, we will wait for some more time. So today will be the last revision class of this um last revision class of this term. So you can call your friends if they haven't joined as well. And we will wait for some more time and then after that we will start the classes. Okay. Good evening, Niranjana. Yes. So yeah, we will wait for 2 more minutes for your friends, for others to join as well. Also, like today will be the last class. So if you have any doubt for the last two classes that we have done, like we have covered two different topics and two different chapters. So if you are having any doubt in that previous classes also, you can ask after today's class. Okay. Okay then. So yeah, we will start our classes. So once again, welcome all to the last class of this term's revision class. Okay, so today we will be dealing with the chapter called gravitation. Like we will be recalling and we will be recollecting the concept that that you guys have already learned in the chapter called gravitation. It's actually a fairly easy chapter to understand. It's because you can actually see things that is happening due to gravity, due to the effect of gravity. So it's fairly an easy chapter, I would say. And like I said in the last class also, you have to understand the concept thoroughly and concept clearly in order for you to, you know, face any kind of questions that comes in your examinations. Okay, so understanding of concept in its correct order is very important. So we will recollect all the concepts that you have learned in the chapter, in this particular chapter called gravitation. Okay, so let us start the classes. So when we speak about gravitation, You guys know, like, am I audible to you guys? Everyone who have joined late, am I audible to you also? Am I audible to you guys? Yeah, okay, fine. So when we speak about gravitation, there is this one interesting story that we have already, like we have heard it many times, right? We have heard it many times that apple falling on Newton's head. It's like a story. It's like an anecdote. So we have heard that, like, the story is literally that, and Isaac Newton, the famous scientist Isaac Newton, was sleeping under an apple tree, and one apple fell to his head. So it got him thinking that why does this apple fell down instead of going upwards? Actually, before that also everything on earth obeyed this law, right? But someone at this point of time, but at that point of time, Sir Isaac Newton had a thought that why did it fall downwards instead of going up or instead of going in some other direction? So that actually, you know, that actually started like that made that made Isaac Newton think about what is this attractive force which is happening in our earth. Why are we not able to fly upwards, or why are we not able to jump um, rather than a certain height? We can only jump. There is a limitation, right? So why are we not able to just fly off like Iron Man or something? He just started having thought, and then came to the conclusion that there is something which is actually pulling us downwards, right? Earth is actually pulling us downwards to its surface, and that phenomenon or that process is known as that phenomenon, or it's actually a force which is acting, right? That phenomenon is known as gravitation. Okay, so I have a question, like, why do things fall back to Earth? This is one basic question that I have to you. So you guys know the reason behind it. What is the reason that things are falling back to Earth? Even if I throw something upwards, even if I have a ball, or if I throw this pen also, after a certain time it will come back to Earth only, right? Come back to the ground, or come back to the space where it is started, right? So the reason behind why things are falling back to Earth is nothing but gravity, which is actually a force, and it's not a force discovered by Isaac Newton. It's a force that was already there. Isaac Newton actually, find out the reason that this is the force that is responsible for things to fall back on Earth. Okay, so why do things fall back to Earth? It's nothing because of gravity. Gravitational force is the attractive force between objects. Okay, so we have learned in the previous chapter, in the previous classes, we have discussed about motion, and then we have discussed about force and laws of motion, and we have discussed different kinds of force. So do you guys remember there is one particular we categorize the forces into two different types as contact force and non-contact force. So we have discussed that in the previous class itself. So contact force means force is always an interaction between two objects, right? You know that force is always an interaction between two objects, two or more objects actually. So there is this categorization called contact force and non-contact force. In contact forces, you guys know that there should be a physical contact between the objects. Whichever objects is under your system or is in play, then there should be a physical contact between those two objects in order for the force to transfer. But there is this second category of force which is known as non-contact force, right? We mentioned one second category called as non-contact force. So in non-contact force, two examples that we mentioned in the last class was, one was gravitational force and the second one was electrostatic force. So non-contact in the sense, what does it mean? Non-contact force means there is no physical contact between the two objects or between the objects in interaction, right? So no physical contact. So gravitational force or gravity is a type of force. It is a non-contact force acting between two objects or two particular things, and due to that, gravity is an attractive force, and due to this particular gravitational force, the Earth is actually attracting all the other body. Similarly, we learned Newton's third law also in the last classes. Particular gravity's third law also has and attracting all. There is one action force, there should be a reaction force. So it's not just the Earth attracting us, we are also attracting Earth towards us. So it's an interaction So it's an interactive force, right? Gravitational force is an interactive force of attraction between two objects, such that both these objects will have force of attraction, and that is known as gravity, and that is the reason why we are falling back to Earth. And we could imagine why, like if I throw this pen, I have this pen, okay, if I throw this pen, it will come back to Earth. The Earth will not go to this pen, right? But I just stated that there is this attractive force between two objects happening. So why not Earth go and why not this pen attract Earth? Why not the reverse happen? Because Earth is so huge that attractive force will not be enough in order to move Earth towards this particular pen. Okay. Yeah, very good. Earth has more mass than the pen. That is the simplest answer. So it's not just Earth attracting us. We are also attracting Earth towards us. Okay. So it's a two-way interactive force, which is known as gravitational force. And the magnitude of force, like how much force is applied or how much force is generated in this particular situation, that is explained by Newton's universal law of gravitation. So Newton's universal law of gravitation answers many scenarios throughout the universe, many scenarios on how each and every object is keeping on attracted to each other. So that is explained by Newton's universal law of gravitation. So what is Newton's universal law of gravitation? Let us look into that. So this is very important in terms of your exam also, and in terms of the concept that you have to learn. Universal law of gravitation states that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. So as we said, gravitational force is nothing but the attractive force between two objects, right? If I'm having two masses, there will be some form of attractive force between these two objects known as gravitational force. So it is a force, so we have to measure the magnitude, right? So what universal law of gravitation is stating that the magnitude of the gravitational force between two objects having two different mass is directly proportional to what? The product of their masses. So let it be M1 and M2. If the masses are two different masses, M1 and M2, it is directly proportional to the product of the mass. And this particular gravitational force, the magnitude is inversely proportional to the square of the distance between them. If the distance between these two masses are, let us say, if it is D, if it is denoted as D, then universal law of gravitation says that the force of attraction is inversely proportional to the square of distance between them. So F inversely proportional to 1 by D square. Okay. So from this you can actually conclude that force of attraction or gravitational force is directly proportional to M1 M2 by D square. Okay. So this is universal law of gravitation. So from this it is clear that it is directly proportional to the product of their mass. Means if the two attracting bodies are having larger mass, means the force of attraction will be larger. Or if the two masses are smaller, also the force of attraction will be smaller, because it is directly proportional to the product of their masses, right? And inversely proportional, this is very important, inversely proportional to the square of distance. So that explains how things are getting attracted towards each other. Like how we attract, if we say I am standing here on Earth and my mass is M1 and Earth has a mass like M2 or something, then the attractive force between Earth and me we can calculate using the same universal law of gravitational formula, and we actually changed the proportionality concept with a constant called gravitational constant. So it will be G M1 M2 by D square. So if I'm standing on Earth, what will be the distance? What will be the distance between me and Earth? So we actually calculate the distance from the center of Earth. So that is the distance. So it's not like we calculate or we measure the distance from the surface of Earth. We actually measure the distance from the center of those objects. Okay. So that is very important. Yeah. So here, if I'm standing on the surface of Earth, and I am having a mass m1 and Earth has a mass m2, the distance between me and the Earth will be the radius of the Earth. Okay. So because we always calculate the distance between two objects from their center of gravity. So by substituting the values, m1 will be my mass and m2 will be the Earth's mass, which we already know, and the radius of the Earth is also been calculated. So by substituting the value, you can or I can calculate how much gravitational force of attraction is happening towards me, or how much attractive force I am applying towards Earth. So that you also can calculate the value with your masses. Actually, with your mass, you can calculate, because the rest everything will be constant. G is the gravitational constant, and gravitational constant, it's also a constant value. M2 will be the mass of Earth, it remains constant only, and D2 the radius of the Earth only, because we all stay on the surface of Earth, right? So it will also remain constant almost, like, and only thing that changes will be our mass, or the object's mass that we are actually want to calculate. So this is not just for the calculation of attractive forces between me and Earth, or between you and Earth. We can actually do this. We can use this particular equation to calculate the force of attraction between planetary bodies as well. So here you can see the example is between the force of attraction between Moon and Earth is calculated by the same equation. So as we said, it's an actually this force of attraction is happening between two objects. Here you can see that F1 is the force of attraction by the Earth towards the Moon, and similarly Moon is also attracting the Earth towards the Moon with the force F2. Okay, but both these forces will be equal. It's like Newton's third law of motion. We have stated that every action has an equal and opposite reaction. So here also both the magnitude of the forces between these two objects will remain the same. Okay, so whatever force the Earth is trying to pull Moon towards the Earth, similar force is applied by Moon also to try to pull the Earth towards the Moon. But we are not moving towards Moon, or Moon is not moving towards Earth, is because of the masses and also because of the balance of this particular gravitational force. Okay. So universal law of gravitation, you can actually expect, like, you will be asked to explain the statement or explain universal law of gravitation. And universal law of gravitation, we will repeat it one more time. It states that the force of attraction, what is it? The force of attraction between two objects having mass. Force of attraction is directly proportional to the product of their masses. If m1 and m2 are the masses, then it will be proportional to the product of their masses and inversely proportional to the square of distance between them. So if the distance is actually doubled, or if the distance is increased, the force of attraction gets reduced much higher, because the rate will be higher, because this is square of distance which is actually acting. So if I say that, if I have a question for you, like, let us say F is the force of attraction between two masses at a certain distance. Okay, let us say it is m1 and m2 are the two masses, and d is the distance between them. So if I am increasing the distance, if I am doubling the distance between these two masses, like I have a mass A and mass B is there, and this is at a distance d. So this is the magnitude of force. F is the magnitude of force. Let us say in the second case, I am doubling the distance. Means I doubled the distance, and now the distance will be 2d between A and B. Then how much will be the reduction, or what will be the change in force? So can you give me the answer, like how much the force will change with respect to the initial force? Yeah, so you can actually calculate, right? It's pretty easy to calculate as well. So what we have to do, the variable that got changed here is distance got changed. Okay, so distance got doubled, means distance has changed from d to 2d. So we know that now they are asking what is the change in gravitational force of attraction. So let us take F, new force of attraction, as F dash for convenience. So it will be, rest everything remains the same only. Mass is not going to change. So m1, m2, because the same mass only we are using. And divided by the distance is now it is 2d the whole square. Okay, because the distance has changed from d to 2d. So what will you get? F dash is equal to g m1 m2 by 2d the whole square is what? 4d square, right? So we can actually write this particular equation as 1 by 4 into g m1 m2 by d square. We can actually take this 1 by 4 outside, and we can club or we can group the way alphabets or we can group the masses and distance together. So g m1 m2 by d square, you already know it is f. It is given as f in the initial case. So this will be equal to 1 by 4 into f, which is equal to f by 4. So the force actually reduces by 1/4. It's not half. The force will not be, see, if the distance is doubled, the force will not get half. Instead, the force will be 1 by 4 because the force is reducing as a square of the distance between them. Okay, so that you have to focus. Like whenever you are calculating, it's actually easy. So you have to substitute the values and then do the calculation so that you will not get wrong answers. Okay. So in another case, instead of doubling the distance between these two objects, what if I actually tripled the distance? Like I changed the distance from d to 3d, then how much reduction or what will be the change in force compared to the initial force? So can anyone answer that, like based on this particular question? Okay, now you got the scenario, like d is the initial distance, so you know that the force of attraction initially will be how much? It is g m1 m2 by d square only. So now in the second case, I have increased the distance to 3 times. I have tripled the distance between these two objects. Okay, so now in the second case, I have tripled the distance. So now A is here and B is at a larger distance from A, and the distance between A and B is 3D. So now what will be the force? Like what will be the change in force? How much will it be? Yeah. Yeah, very good, John. So what about others? Like, did you got the concept of how this force is changing? So if I am changing the distance from A and B to 3D, what will be the change? What will be the change in force compared to the initial force F? Will it increase or will it decrease? You guys can calculate and tell me the answer. It's actually easy. So what will it be? Yeah, very good, Purajita. It will decrease. So how much it will decrease? Well, that is a question. Like you have to have a magnitude. So initially the force was F. So how much it will decrease compared to the initial force F? So this is also similar, like the way that we have already calculated in the previous situation. So here you just have to change the variable. In the previous situation, it was instead of d, it was 2d. Here instead of d, it is 3 times d. So let us say f dash is the new force. So it is actually very easy. M1 m2 by 3d is the new distance between those two objects. The whole square. You should not take 3d square and 3d the whole square is different. Okay, so you should be careful. It is the distance squared. So the distance is 3d, then it should be the whole squared. Okay, so this will become g m1 m2 by, it will become 9d square, right? So this will be f by 9 only. Okay, so this is how these kind of questions you might expect in your exams, like how much change is there in the gravitational force of attraction between two objects. They will actually give you change in variables. Like they will tell that the mass of one object has increased and the mass of another object has decreased. So you have to calculate how much change is happening. So this is the way. So basically you should know the particular universal law of gravitation equation and the concept behind it. Okay. Understood? Okay. Okay, so next is uh, this one another question we will solve. Why is the universal law of gravitation known as the inverse square law? This is one previous year question that I was already asked. So why is the universal law of gravitation known as the inverse square law? The answer is pretty simple, right? So you guys can answer it by yourself. Why is it known as inverse square law? Universal law of gravitation is sometimes known as inverse square law. So what is the reason? Can you state the reason why is it called so? You know that what does it universal law of gravitation states? It states that the attractive force between two objects will be directly proportional to product of mass of two objects and inversely proportional to the square of distance between them, right? So that is why it is known as inverse square law, because it is inversely proportional to the square of distance between the two masses. Okay, so that is the reason why it is known as inverse square law. Okay, yeah, force is inversely. Very good, Anjali, very good, John. That is the reason why universal law of gravitation is also known as inverse square law. Okay, very good. So now let us move on to our next particular topic known as free fall. But before going to that, we'll just, so we have now discussed what universal law of gravitation is, right? So what is the feature, or what is the importance of this particular universal law of gravitation? We said that I already mentioned that this universal law of gravitation help us to find out the force of attraction, or help us to know the reason behind the forces of attraction in planetary bodies like sun, moon, everything, and also between Earth and the objects which are around Earth. Okay, so universal law explains several phenomena. The universal law explain the force that bind us towards Earth. Why we are not falling, or why we are not flying from the Earth? Because of gravitation, and it is explained in universal law of gravitation. Okay, then the motion of moon around Earth, that is also due to gravitation, and it can be explained using universal law of gravitation. Then motion of planets around sun. We know that every planets are circulating the sun, and there is this particular gravitational force which is actually enabling the planet to rotate in their orbit. So that is also explained by the universal law of gravitation. And we have tides actually, like during night time, the tides will rise on the sea surface. If you check out, you can actually see those in videos also. The tides will rise, and the rise in tide is due to the gravitational force of moon to the earth. Moon is actually applying, or moon is actually attracting the earth, right? So that attractive force is influenced by that attractive force gets influenced to the sea, or the water in the sea, and there will be tides. So the water is actually trying, the gravitational force of moon is actually trying to pull that water, so that we will get high tide and low tide, which is useful in many cases. We can actually generate a lot of energy. Tidal energy is there, which is a renewable source of energy. So we can actually generate power with those tides. And the reason for tides on Earth is due to the gravitational force of attraction between moon and sun. Mainly it is dominant force is because of moon only, because moon is the nearest object to the earth, right? So since it is more nearer than the sun, the gravitational force is more compared to the sun's gravitational force. So the tides will rise mainly due to the gravitational force of attraction by moon towards the earth. Okay, so these are the importance of universal law of gravitation, which is you have to note these particular points down so that you can answer that in the exam when it is asked. Okay, so now the next concept is pretty interesting concept known as free fall. So free fall is something that we can actually experience, but it's not it means you have seen skydiving. Skydiving is a sport. Okay, it's a professional sport, and it is done using many safety techniques and all. So when one person skydiving, how does it happen? You might have seen skydiving in movies and all, where they will actually fly you towards a particular height in an aircraft, and from the aircraft you will be having your safety gears. Lot of safety gears are there, parachute are there, and many different kinds of suits are there. Okay, and then you will jump from the plane, and then when you reach particular height, you will release your parachute so that you can safely land on earth, right? So this is known as free fall. And like even if you drop something, even if I drop this pen, it will fall down towards the surface of Earth, right? Or if even if you drop something, if you drop a ball, anything, at that moment and when it is traveling towards the surface of Earth, that object will be in free fall. Okay, free fall is just something falling back towards the Earth or something falling towards the Earth, so that, and there is no any other force. Okay, here if I am dropping this pen, it will directly fall downwards only, right? There is no any other force to interact. But if I drop something lighter than this pen or particular something, if I drop this particular paper or something, like it's not necessary that this paper will fall down perfectly straight, because there is air is around us, right? So this air will have some resistance, and due to this this paper is having very light weight, the air resistance will catch and it will fall in a zigzag manner. So if we create, or if we consider a space without air, and if I um, at the same moment, if I just let this pen and this paper go, both will fall at the same time, and that is known as free fall. So free fall is a motion which is only under the force of gravity. Only force of gravity acts on this particular case when you are actually falling freely, or whenever an object is falling freely, there is only one force, which is force of gravity is acting, and all the other forces are not acting, and so it will keep on falling in a straight line. And since only one force is acting, I want to ask you one question. If I'm dropping this pen and if I catch it at this particular height, so for a certain moment, this is under free fall, right? So I want to ask you one question, whether the speed of this pen will increase or not. Or if I put anything, if I just drop anything, just a ball or something, while falling, does the speed increase or the speed remains constant? So what do you think? Speed increase or not? Increase. Does the speed remain constant on free fall, or does the speed increase, or does the speed decrease? Yes, Vignesh said that speed increases during free fall. What about others? What do you think? Does the speed of the object under free fall increases, or does it decrease, or does it remain the same only? Yeah. So obviously, yeah, very good, John. So obviously the speed has to be increased, right? Because whenever we are dropping something, if I'm dropping this, before dropping, what is the velocity of this particular object? What is the velocity? I'm holding it and it is stationary, right? So stationary means what? The velocity is zero only. So when I drop, it starts falling. And obviously the velocity has gone from 0 to 1, 2, 3. So like that, velocity is keeping on changing and the speed is actually increasing. So it means that the velocity or the speed changes means what kind of motion is it? What does it imply? So it's an accelerated motion, right? So whenever an object is under the influence of gravity and falling freely without any other forces, then that motion will be an accelerated motion. Okay. So the object which I am dropping, let us say I am dropping a tennis ball. So the object which I am dropping, initially the velocity will be 0, and then while going down, the velocity keeps on increasing. It means that the body is getting accelerated. And what is the rate of acceleration here? So that particular acceleration is actually known as acceleration due to gravity, because the body is getting accelerated, or the speed is increased in the body due to the force of gravity. So it is known as acceleration due to gravity. And in Earth, what is the reason for this acceleration? It is the force of gravity, right? So in Earth, the acceleration due to gravity is a constant, and the value, what is the value of acceleration due to gravity? On Earth, the value of acceleration due to gravity of the Earth is 9.8 meter per second square. So acceleration due to gravity, AG, or we actually simply call it G, small letter G, which is 9.8 meter per second square. So what does this mean? So it means that, yeah, rounded off to 10 at particular cases. If it's only stated, then only we can round it off to 10. Like in certain calculations in exams, they might tell you that you can consider the acceleration due to gravity as almost equal to 10 meter per second square. If they are stating that, then you can use acceleration due to gravity is 10 meter per second square during calculation. Otherwise, the value of acceleration due to gravity on Earth is a constant and it is 9.8 meter per second square. So what does this mean? If I am dropping a tennis ball from a certain height towards the ground, okay, when each second passes, the velocity of this particular ball increases by 9.8. So after 1 second, the velocity will be 9.8. And then after 2 seconds, the velocity of the ball will not be 9.8 but 19.6. The velocity will keep on increasing. In each second, the velocity is increasing by 9.8 meter per second. So that is what it is meant. Okay, so it means that the body is keeping on accelerating and in a uniform rate. Okay, it is accelerating at a rate of 9.8 meter per second square. Each second, 9.8 meter per second speed is increasing. Okay, all clear? So now we have discussed what is acceleration due to gravity. Now the another thing that we are going to discuss is how this acceleration due to gravity is influencing the motion or influencing the livelihood of ourselves. Okay. So next we are going to discuss a particular topic called mass and weight. So mass and weight might seem similar because we are actually measuring, we are actually measuring some similar kind of quantity, but there is this significant difference between both these quantities. Okay, mass and weight is not the same. So what does mass means and what does weight mean? Mass is nothing but the amount of matter in a substance. Okay, so it's almost a constant. The amount of matter contained in a substance is known as what? Mass. But as I said, when we go to some places or when we are actually measuring the weight or measuring, we have seen, let us say, I will tell you one example. When we go to shop and something, we will be weighing the we will be using a weighing machine and we will actually measure the quantity. We will measure the quantity of that particular result. Let us say 1 kilogram of sugar. We are actually measuring the weight because we are standing on Earth. We are standing on the surface of Earth, so that we are always attracted by the Earth by a certain amount of force, right? So there is this particular force of attraction by the Earth towards us all the time. It's not just at times we have this. We are able to walk or we are able to stand here on the surface because of that attraction only. So weight is actually the force with which Earth is attracting an object. If I am having, if let us take me for example, if I am having, if I'm standing on Earth, it means that Earth is actually attracting me with a certain force, and that force we can find out by Universal Law of Gravitation, right? So this attractive force, this particular attractive force by which the Earth is attracting me is known as weight. Okay, so it is the, what is weight? It is the attractive force by which Earth is attracting, by which Earth attracts anything, attracts not just me, any object, attracts any object. So that is weight. So we can say that there is a clear distinction between mass and weight. Mass is the amount of matter and we actually use the unit of mass as kilogram. Okay, but we never use the unit of weight as kilogram because we already stated that weight is not just the amount of matter or not just the sum of all the matters inside a body, but it is the force of attraction by which Earth is attracting. Okay, so since it is a force, we actually use Newton or the unit of force in order to denote the weight of an object. Okay, so if I say the weight of an object is 50 kilogram, it is wrong. 50 kilogram is not the weight, but it is the mass of an object. It can be the mass of an object. But if I say the weight of an object is 50 Newton, then this is correct. Okay, so we actually denote weight usually by the unit called Newton. So let us calculate how the universe, like how gravity is affecting the weight. So we know that we have already told that it is the force of attraction by the Earth towards any object. So according to Newton's second law, we know that F is equal to mass times acceleration, right? So here the force of attraction is due to the gravity only. So here this is acceleration only, right? So here in case of Earth, when we are standing on the Earth, the acceleration that is acted upon the object or acted upon us is nothing but acceleration due to gravity denoted by small letter g. So the force of attraction will be m into g, mass times the mass times acceleration due to gravity. So weight of an object, if we say denote it by w, weight of an object will be mass times mass of that object times the acceleration due to gravity, which is very important. So if I am saying that, let us solve one particular example. Okay, if I am saying that I have a body having a mass 5 kilogram, then what will be the weight? Weight, is it going to be 5 Newton or what will be the weight? And you can consider, you can take acceleration due to gravity g as 10 meter per second square. So what will be the weight of the object on Earth? So if I am having an object of mass 5 kilogram, so I want you guys to answer this particular question. If I am having an object with a mass of 5 kilogram in my hand, what will be the weight of that object on Earth? Yeah, okay, fine. Very good, Anjali. So yeah, you can take acceleration due to gravity as 10 meter per second square here. So it is, we know that weight is nothing but mass times acceleration due to gravity, mass into acceleration due to gravity. So mass is 5 kilogram and acceleration due to gravity, you can take it as 10 meter per second square. So this will be 50 and the unit should be clear. Okay, it should not be in kilogram, it will be 50 Newton only. Okay, so then only we can specify that this is not mass given, it is the weight given based on the unit. Okay, so 50 Newton is the correct answer. So these kind of questions you can expect in your exams. Okay, and we said, and I mentioned that weight is the force of attraction of Earth towards an object, right? So what if I am, instead of Earth, what if I am going to some other places? Let us say Moon is the most nearby planetary object to Earth, right? So what if I'm saying that I went to Moon and I measured my weight? So will it be same? Will the weight be same? Or will there be any difference in weight? Will the weight be same if I am measuring the weight of an object after going to Moon? Yeah, it will not be the same, right? It will be different, because why is it different? Yeah, very good, Lakshmi. So why is it different is the acceleration due to gravity. The acceleration due to gravity on Earth is the amount of acceleration on which Earth actually tries to pull an object, right? So it depends on many factors. It depends on many constant known as what? Depends on mass of the object, right? Mass of Earth. So since mass of Earth and mass of Moon are not equal, the acceleration due to gravity on Moon will be different for sure, right? So since there is a difference in masses, the acceleration due to gravity will be different. And because of the difference in acceleration due to gravity, there will be difference in weight of the object on Earth and Moon. So there is a particular relation between the weight of an object on Earth and Moon, right? So actually Lakshmi told the answer as well. Yeah, gravity is low there in Moon. So the relation between weight on Earth and weight on Moon is weight on the Moon. Let us say it, W Moon is actually weight of an object. Weight of any object on Moon will be 1/6 times the weight of the object on Earth, because the acceleration due to gravity is 9/8/6. So acceleration due to gravity is also 1/6 of that, sixth of the acceleration due to gravity of Earth. Okay. So how much will it be? 1/6. Yeah. So if I'm saying that if I measure if I have an object which is having a weight of 60 Newton here on Earth, okay, 60 Newton on Earth, and I took the same object to the Moon and then I measured the weight again. So what will be the weight there on the Moon of this same object? Yeah, it will be very good. 60/6, which is equal to 10 Newton. So it will be 10 Newton weight showing on the weighing machine on Moon. And what is the reason behind that? The reason is that the acceleration due to gravity is 1/6 of the acceleration due to gravity here on Earth. Okay, if g is the acceleration due to gravity on Earth, then so, or if g of moon, gm is the acceleration due to gravity on moon, is equal to the acceleration due to gravity of Earth into 1/6. Okay, so that is the reason why weight of an object is not a constant, but it depends on the place where you are staying. Even in Earth also, we can actually feel different weight. Even if I'm standing near the equator, and if I'm going towards the pole, there will be a change in weight. And if I measure my weight, it will not be the same, because there is a slight difference in the acceleration due to gravity on the equator and on the poles. The reason behind that is the particular shape of the Earth. Okay, Earth is not actually a perfect sphere. It's actually a sphere which is bulged towards the equator. Like it's like a flattened sphere. The poles will be nearer towards the center, and the equator is more far away from the center. Okay, and this particular shape is known as geoid actually. So that you will learn in your higher classes about the shape. So this shape is known as geoid, and the shape is such that, yeah, very good. So the shape is such that it's actually bulger. It's actually bulged outwards towards the equator. So it means that if you look at the distance from the center towards the equator, the distance is more. And towards the pole, the distance from the center to the pole is less. So I have a question, like, where will the force of acceleration due to gravity more, or where will be the gravitational force more? Is it more on the equator, or is it more on the poles? You should be very careful while answering. Like, will the force on the, where will the force be more? Is it more on the equator, or is it more on the poles? So you have mentioned, you guys have told that the Earth is having a shape known as geoid, and also the poles are closer towards the center, right? So according to Universal Law of Gravitation, we know that if something is closer, it means that the force of attraction or gravitational force will be more or less. If the distance between two masses are less, it means that there will be more force of attraction between those objects, right? Based on Universal Law of Gravitation or inverse square law, we know that if two bodies are there and if they are closer towards each other, there will be more attractive force than if the bodies are far away. So a person standing here on poles is actually closer to the center of Earth, right? So it means that the gravitational force here on pole is more than the equator. So if you measure the weight, so due to that reason, g on poles, acceleration due to gravity on poles is slightly lesser than g on equator. Okay, so if you measure the weight on the poles, you can clearly say a slight difference. It's not a big difference. Okay, you can see a slight difference, as the weight measured on the poles will be more than the weight measured on the equator. So weight on the poles is slightly greater than weight on the equator. Okay, and the reason behind that is due to the shape of the Earth only. Okay, and we actually, this 9.8 is actually the average value of acceleration due to gravity in the pole and the equator. Okay, so it's in between, it's in the middle range that we are taking 9.8 throughout the Earth. We will not consider like acceleration due to gravity of poles different, and will not consider acceleration due to gravity on the equator as different while doing calculation, because it will be complicated, right? So you guys have to remember more than two acceleration due to gravity values, which will again become more complicated. So we actually take the average of this particular, and that average is nothing but 9.8 meter per second square. Okay, clear? So now we will move on to our next topic. Yeah, now we already mentioned this thing, weight of the object on the moon will be 1/6 times the weight of the object on the Earth. Okay, so based on that, if I'm giving you one question, or else if you can also get the reverse kind of question. Let us say that if I have an object having a weight of how much, 5 Newton on moon. Okay, so I came back to Earth and I measured the same object here on Earth. What will be the weight on Earth? What will be on Earth? What will be weight on Earth? Yeah. So it's also easy, right? Yeah, very good, John. Very good. So it's what will be the weight on what about others? You got the idea, right? How we can calculate the very good, Anjali. So if I am having an object having 5 Newton weight on moon, so we know that weight on the moon is 1 by 6 times weight here on Earth, right? WE. So I know that this is 5 Newton. So this will be 1 by 6 into W on Earth. So what? It's very easy. Just have to cross multiply. Weight here on Earth will be how much? 5 into 6, that is 30 Newton, right? So these kind of questions that you can expect based on this particular concept called mass and weight in your exams, okay? So now we are going to step into another particular concept called thrust and pressure. So thrust and pressure is an important concept that you should be understanding, or you have to understand this particular concept, because in your higher classes also you will learn a lot about pressure, different kinds of pressure acting on Earth, and how to calculate the pressure acting. So pressure is something that like Newton's law of motion, pressure is something that you will also learn more about in your higher grades. Okay, so thrust and pressure. Before that, I have to explain one scenario. Like you have all been taken injections, right? Even I have taken injections at different point of time in my life. So most of them, I am afraid of injections. So most of you, I don't know, but you might also be afraid of injections because of the pain that is causing, right? I am really afraid of injections here. So I want to ask you a question. Instead of this needle, if the nurses or if the doctor is using this pen actually and trying to give me an injection, will this pen go inside? Like it will obviously go inside if I put that much amount of force into it, but there is this difference. Why are they using this much sharper objects in order to give injections and all, instead of using smoother objects, so that we will be having less pain? Why are they using that? Because there is this particular effect called pressure, and that is the reason why they are actually using this sharp syringes to give injections and all. So what is pressure? So if I'm saying that if I have an object, okay, if I have an object, and let us say I have an object and I'm actually trying to pull it vertically down. So it means that I am applying a force which is perpendicular to my palm, right? This force, this finger is actually perpendicular to the palm, and the force is also acting perpendicular to the direction, right? So whenever we are applying a perpendicular force, that perpendicular force is termed as thrust. It's another name for force. Thrust is just a force only, but in a certain direction. Thrust, we can call a force thrust whenever the force is perpendicular to an object. If I, instead of perpendicularly applying this particular force, if I am applying it in an deviated or in an angle, we cannot call this force as thrust, okay? Because it is not perpendicular to my palm, right? It is actually at a certain angle. So then we can only call this as force. But if I am applying it directly perpendicular, or the angle is 90 degrees, then I can call this force as thrust. Okay, so thrust is the vertical force acting on an object. Okay, clear? So it is the vertical force acting on a surface or acting on an object. Okay, now going into pressure. Pressure is actually the measure of, the effect of thrust. Okay, how much thrust you are giving or how much force you are applying to an object. Pressure is the measure of how much force. Like it's a measure of force acting per unit area. So if I'm having a unit area surface, and if I'm giving a vertical force known as thrust, then we can calculate pressure as it is the force acting per unit area in a surface. Okay, so it's literally the effect of force that is acting on a surface. So that is why we actually feel when we are actually being taken injection, the pressure will be more, and that is why we are feeling more pain, because more force is acting onto that body. But if I am actually trying to push my hand using my finger, I will not feel that much pain, because the pressure acting from the tip of my finger is less than the pressure acting from the tip of the syringe. So that is the reason here why we are able to create more pressure. Okay, so as I said, thrust is just a force. Thrust is the vertical force acting normal or acting perpendicular to a surface. Okay. And pressure means the normal force or the perpendicular force acting per unit area of that surface is called pressure. So we can denote pressure as pressure is nothing but force times area. So from this relation, it is clear that pressure increases when force increases, right? Because from this relation, it is clear that pressure is directly proportional to the force applied. No doubt, right? Similarly, pressure is inversely proportional to the surface area of that surface. Okay, so if the surface area is decreasing, what does it mean? Pressure will increase. Okay, or if the surface area is increasing, what will happen? Pressure will be lower. So that is why for syringes, that is why we have sharper needles. Okay, we are sharper end, because if you look at the surface area will be very small in sense like millimeters only. Surface area, the tip of the needle will be very small. It means that the surface area is very small. So the pressure created here will be very high. So it will be easier for us to give injections. Okay, and this you can see in knife also. Like the reason why knife is so thin and so sharp is that the surface area will be reducing, so that there will be more pressure, and it will be easier for us to cut vegetables because we are applying a lower force. Since the area is less, pressure generated will be more. So it's easier for us to cut vegetables. Okay. Yeah. So that is the reason. And from this, it is clear that pressure is force times area, force divided by area, and unit of pressure is called as what? Unit of pressure is called as Pascal. Okay. And 1 Pascal, and it is denoted by capital letter P and small letter a. 1 Pascal is equal to 1 Newton per meter square, because we know that pressure is equal to force divided by area, right? So what is the unit of force? Unit of force is Newton, and what is the unit of area? Meter square, right? So 1 Newton per meter square. Newton per meter square is also the unit of pressure. 1 Newton per meter square is equal to 1 Pascal. Okay. So pressure is not only acting on solid objects. Okay. So cylinder is a solid object. This pen is a solid object. My hand is a solid object. So pressure is something which is not only acting on solid objects, but we can see pressure in another objects also. Like we can see pressure in fluid. Liquid also exert pressure on surfaces. Likewise, air also exert pressure on surfaces. So anything that has a weight, anything that can apply a force into another object, then there will be some form of pressure acting. Okay. So we have different categories of pressure as well. We have liquid pressure, which is generated by the liquids. Okay. Because if you are having a bottle and if you fill it with water, the water is actually having contact with the surface of the bottle, right? So the water will also apply what? Perpendicular thrust towards the bottle. So since there will be a perpendicular force acting, there will be pressure for sure, and that pressure we generally call it as liquid pressure. Okay, because it is acted by the water or by any kind of liquid. Likewise, we have this particular air can also apply pressure, because air has matter in it. Air can apply weight onto objects, right? So the pressure generated by the air around the earth is known as atmospheric pressure. Okay, atmospheric pressure, because if you see, like if this is the surface of earth, okay, we have around us. We have air around us, right? So there are different layers of air stacked upon each other. Okay, so what happens? All these layers of earth is actually exerting a weight onto the surface perpendicularly or normally to the surface. So due to this weight of the air, there will be a pressure acting on the surface of the earth known as atmospheric pressure. Okay. So its pressure is not only happening between solid surfaces, pressure happens between liquid surfaces, and liquid and solid surface also pressure is acted upon by air also. Okay. So we have learned what pressure is, and pressure, the formula for pressure, you should be always have that in your mind. Pressure is nothing but the force acting per unit area. Okay. and this force will be always perpendicular to the surface. Then only we can say that pressure is acting, or then only we can feel the effect of pressure. Okay. So next, sorry. So next what we are going to learn is we are going to learn particular concept called buoyancy. So you have seen this. This is something known as iceberg. Okay. If you have seen Titanic movie, this is one main character in Titanic movie where the Titanic is a big ship and where it hits an iceberg and sank. Okay. So this is some iceberg is a big crystal of ice or a big chunk of ice actually floating in the sea in lower temperature in Arctic Ocean or something. So in order to understand buoyancy, like you can do a simple experiment at your home also. Buoyancy is a force. Buoyancy is also another kind of force. And how is that force acting, that we are going to discuss now. So buoyancy, if you are taking one bucket of water, like you can do this at your home also. Like take a bucket of water and try to immerse your hand inside. So when you are trying to immerse your hand inside the bucket of water, you will feel you'll feel something pushing upwards. Like you cannot just simply dip down your hand, but there will be some form of resistance. So you can actually feel, if you loosen your hand, you can feel something is pushing upwards. So it means that there is a force which is actually, there is a vertical force, or there is a force which is actually trying to push upwards, and that force is known as what? Buoyancy. Okay. So buoyancy is similar to pressure. Buoyancy is also similar to thrust. Buoyancy is also a vertical force acting on an object. Like if a fluid will exert buoyancy on another object, which means that a fluid will try to exert a vertical force upwards against the force of gravity. So you know that, like we know that weight is actually due to gravity only, right? Weight of an object is due to gravity. So weight always act downwards. Okay. The weight of an object always act, W will be the weight of an object, it always act downwards. But if you are putting that object having a particular weight into a bowl of water or into a container full of water, this water will try to exert an upward force onto the object, because we have learned Newton's third law of motion, but it will not be equal to, it's not necessary that it will be equal to the weight, and that vertical force is known as force of buoyancy, or simply buoyancy. Okay. And due to this buoyancy only, there are certain things, like we are able to float. There are things which are able to float. Ship is able to float. So it is due to the buoyancy only that things are able to float on the surface of water, or things are able to sink on the surface of water due to buoyancy force. So we will see how things can sink on water and how things can float on water. So one important thing is that we already mentioned buoyancy being a vertical upward force. So whatever object you are immersing in water, or whatever object you are immersing in a fluid, it will always have buoyancy, and the buoyancy force will be acting upward. So the natural tendency will be that the water will try to push the body upwards, not sink. Okay. But the buoyancy force is actually depending on the density of the liquid. Okay. This buoyancy force depends on the density of the liquid which we are using. So now we have two examples. We have one nail and we have one cork or thermocol or something. Okay. So if we put both these together in water, we can see that nail will go down and the thermocol will stay afloat. Okay. So what is the reason for that? The reason is that nail is an object made of metal, right? So metals usually have higher weight or higher density. So nail is having higher weight. Means the density of the nail is more than water. Density of nail is more than water. Therefore, the buoyancy force is lesser. Okay. So here the weight will be more. Weight of the nail is more than the buoyancy force acting on the nail. So that is the reason. Since weight is higher, weight is more than the buoyancy force. That is the reason the nail will sink. And if you consider the thermocol, the density of that particular thermocol is less than that of water. So we know that buoyancy depends on the density of liquid. So force of buoyancy, if the density of liquid is more, means more force of buoyancy. So in case of thermocol, the weight is lesser than the buoyant force. So buoyancy force is more in terms of thermocool's condition. So that is the reason it is able to float in the upper part. Okay. So the reason why objects sink and float is due to the difference in density, and due to the difference in density, what will happen? There will be difference in the buoyancy force acting on the object due to the difference in density. So that is the reason why objects can stay float or objects will sink down depending on the density. If I say that I have a metal pen, okay. So if I put this metal pen in a cup of water or in a mug of water, it will go down. And the reason is this metal pen has density more than the density of water. So since the density of water is less than this metal pen's density, the buoyancy force generated will be lesser. So the weight will be more because this particular pen has more density. So since weight is more, it will go down because that buoyancy force which is acting upward is not able to pull it upward, right? So that is the reason objects will sink and objects can float. Okay. So now we have mentioned what buoyancy force is. Buoyancy force is an upward force acting on an object when it is immersed in a fluid, right? Immersed in a liquid. So what is the magnitude? How can we say that it's not equal to, in every condition, it will not be equal to the weight of the object, but there will be some difference. So how are we going to calculate the magnitude of the buoyancy force? So if I ask you what is the buoyancy force acting here, how can we calculate? So there comes the answer. We can actually calculate the buoyancy force. We can actually calculate the magnitude of the buoyancy force using Archimedes principle. So Archimedes found out a way to calculate what? To calculate the buoyancy force acting on object, right? Because we already mentioned that buoyancy force, we know there is something which is trying to pull the object upwards whenever it is immersed completely or partially in a liquid. Okay. But we doesn't know how to calculate how much force is acting. Like how much force is acting is still a question mark. So Archimedes came up with the principle called Archimedes Principle. What does it state? Archimedes Principle states that when a body is immersed fully or partially in a fluid, it experiences an upward force. And this upward force is nothing but buoyancy, right? So the magnitude of buoyancy will be equal to the weight of the fluid displaced by it. So you can actually, what does it mean? What it means is that if you are taking a mug full of water, okay, full of water, and if you are immersing something in it, let us say if you are dipping some rubber ball, or if you are dipping something, if you are dipping a metal plate, let us take a rectangular block, metal rectangular block. If you are immersing it in the container having full of water, you can see that some amount of water will be going outward, right? Because it's already full, some amount of water will be going outwards. And the amount of water that goes outwards, if you collect it, if you are collecting it in a container, and if you measure the weight of that spilled water, like if you measure the weight of the water that went out from the container when you immerse this metal block, then that weight will be equal to the buoyancy force acting on the object. Okay. So this much weight will be acting on this particular metal block as buoyancy force. That is what this Archimedes principle means the upward force or the buoyancy force is equal to the weight of the fluid displaced by the object, by this particular metal block. Okay. So that is how we can actually calculate the buoyancy force acting on an object. So whenever we are dipping something, or whenever an object is immersed in water, obviously the metal block has more density, right? So it will sink in water and some water will spill out. Let us consider another example, another case where we are actually taking a container full of water. Then instead of a metal block, what if we immerse the thermocol block or something? It will stay float, but some portion of thermocol will remain underwater, right? So due to this, there will be some portion of water which is actually spilled out, because you know that it will not be on the surface. Some portion of the thermocol will be inside the water. So that much amount of water will be spilled out. So if you collect the spilled out water and again if you measure the spilled out water, you will get the buoyancy force acting on this thermocol piece. Okay. So you can calculate the buoyancy force acting on this thermocol piece using Archimedes principle. So that is what Archimedes said. And this is this image is actually like he was given a task by a king to understand whether the crown is made of fully gold or not. So he actually he started thinking a lot of ideas, and one day when he went on to take a bath on the bathtub was full, and he actually entered the bathtub. So some amount of water actually fell down from the bathtub. So then he understood that whatever amount of water that got spilled out of the bathtub is equal to the weight of Archimedes, or weight of the body. Okay. And so not weight of Archimedes, but the weight of the fluid displaced is equal to the buoyant force. So that much force is actually trying to act upward on the body. So this is what this image is about. And Archimedes principle is to calculate the buoyancy force, to know the magnitude of the buoyancy force. Okay. So you understand what buoyancy force is. It is the upward force acting by an object when it is immersed in a liquid. So the magnitude of buoyancy force FB can be calculated using which one? Archimedes principle. So you can expect question about Archimedes principle, why Archimedes principle is used, or what is Archimedes principle also you can expect. Okay. So this is what we are like, this will be the last topic of this particular chapter, Archimedes principle. So you got an idea about what buoyancy is and how we are able to calculate the magnitude of buoyancy, right? We actually use Archimedes principle in order to calculate the magnitude of buoyancy force acting on the object. Okay. So now we will just summarize what we have learned so far. So initially we have discussed what gravity is, right? Gravity, what is gravity and what is gravitational force we have discussed. Then we have discussed one important law, which is known as Universal Law of Gravitation. So Universal Law of Gravitation is used in many cases in order to explain how we are able to stand here on Earth, or how planets revolve around sun and all. Universal Law of Gravitation we discussed. So what does it state? The force of attraction F is equal to G m1 m2 by d square, which means that the force of attraction is directly proportional to the product of the masses and inversely proportional to the square of distance between them. Okay. Then what we learned? Then we actually went on to learn free fall, and we actually mentioned a particular acceleration called acceleration due to gravity, right? Acceleration due to gravity, and how this acceleration due to gravity will affect the weight of an object. So we know that weight is nothing but the mass of the object multiplied by the acceleration due to gravity. So weight is m into g. Then we went on to learn what is called as thrust and what is called as pressure. Okay. So pressure is what? Pressure, if you are denoting it by P, pressure is the force acting per unit area, right? And the unit of pressure is Pascal. Okay. So it is the effect of force acting on an object. So from this equation, it is clear that if pressure is directly proportional to the force acting, and pressure is inversely proportional to the surface area. So it means that if surface area is reducing, the pressure will increase. Okay. So that you have to understand the concept. That is why we are making the edges of the knife very thin and very sharp, because the surface area will be less. So those are the applications of pressure. Okay. Then we learned a term called buoyancy. Buoyancy, what is buoyancy? It is the upward thrust or the upward force acting on a liquid, acting on an object when it is immersed in a liquid. Okay. So it is buoyancy will always depend on the density. This particular buoyancy will depend on the density of the liquid taken. Like whichever liquid you are immersing an object, the density of that liquid matters on buoyancy. And how do we calculate buoyancy? How can we find out the value of this buoyant force or force of buoyancy? Is we use Archimedes principle for that. Okay. So Archimedes principle states that whenever we are immersing an object fully or partially in a liquid, the buoyant force or the upward force acting will be equal to the weight of the fluid displaced by the body. Means weight of the fluid that is displaced from the particular object is known as the buoyant forces. Okay, so that is stated by Archimedes principle. So these are the things that we have learned so far in this particular chapter. So you can expect mainly questions from Universal Law of Gravitation, and also you can expect questions from the weight and mass and weight. You can expect some questions because you will be given weight on Earth and you will be asked to find out the weight, not just on Moon, but maybe some other planets also. They will give you the value of your acceleration due to gravity on that particular place. Okay, so these are the things. So that's it for today's class. So if you have any doubt, you can ask me directly, or not just about this chapter. If you have doubt in the previous classes or in the previous chapter also, you can ask me here, or you can just type it on the chat box so that I will give the reply. Or else you can leave. If you are not having a doubt and if you are clear with all the concepts, then you can leave, and all the best for your exams as well. So see you again after some time. So if you are not having doubt, you guys can leave the class. Okay. So I assume that you understood what we have learned so far. Like, so all the previous classes also, everything is clear to you, right? What we have learned so far about force, we have learned many things about motion. We have learned many things about force and how force affects motion also. And today we learned about gravity, which is an interesting topic also. So everything is clear for you guys, right? Okay, then bye. So I am assuming that you are having no doubt. So all the best for your exams. Bye.